Good afternoon. I will make this discussion brief and concise. It will be the last topic on the integration of partial fraction. So, as a last example under integration under partial fraction, I will give you an example of a unique problem. Okay, let us start, guys. Integration by partial fraction. We are done with the linear factor, repeated linear factor, quadratic factor, and repeated quadratic factors. So as a last discussion on partial fractions, I will give you a unique problem. Okay, let us start. Try to evaluate the integral of sine of theta differential theta over the quantity 1 minus cosine of theta square times the quantity 2 minus cosine of theta. For the meantime, the given problem is under trigonometry. So how could we transform this problem into partial fraction? Okay, let's bring out the solution. We use trigonometric substitution first, okay. We let x equal to cosine of theta. Trigonometric substitution for the meantime before we will go with the integration of partial fraction. If x is equal to cosine of theta, dx will be negative sine of theta differential theta. The derivative of a cosine is negative sine, so this should be negative sine of theta differential theta. Multiplying both sides by negative 1, this will become sine of theta differential theta. Dx times negative 1 will be negative dx. So after bringing out this one, try to bring it back to the original problem. Okay? My board is flipping, but it's been up by several inches, so you could actually see my total lecture here. Substituting these values here back to the original problem. Sine of theta differential of theta is negative dx all over 1 minus, if x is equal to cosine of theta, this will become 1 minus x quantity square times the quantity 2 minus x. So this is now an algebraic function, right? Algebraic function in which the denominator contains linear factors. We got one linear factor 2 minus x, and we got one linear factor 1 minus x, but it is repeated because the power is actually 2. So this falls under linear factor and repeated linear factor. Okay? So to take the integral of this should be equal to the integral. Supposed to be on the right, it will be 3 partial fractions. For the first linear factor which is not repeated, the equivalent will be a over 2 minus x. The repeated linear factor 1 minus x, you got 2 partial fractions. It should be b over 1 minus x, okay, to the first power, or just simply x, just simply 1 minus x, plus c over 1 minus x quantity square, close bracket dx. Meaning, to try to take the integral of this should be the integral of the summation of this. But for the meantime, we do not know the value of a, b, and c. So let's proceed with the computation. Minus dx for the meantime, we will let for the meantime, forget for the meantime the integral sign. Let's bring out the partial fraction, okay. This is the partial fraction actually. Why this is minus 1? We remove dx for the meantime, so what remains here is negative 1 over the quantity 1 minus x quantity square times quantity 2 minus x equal to a over 2 minus x plus b over quantity 1 minus x plus c over 1 minus x quantity square. Then To simplify this one, multiply all terms by 2 minus x times 1 minus x quantity square. You multiply this product here to all the terms. So what will come out on the left hand side? This will cancel, this will cancel, this will cancel, okay? So what remains on the left will be negative 1. On the right hand side, a will be, this will be eliminated, okay? So the multiplier will only be 1 minus x quantity square. For b, the multiplier will be 2 minus x, and 1 of these times 1 minus x. And for c, 1 minus x will disappear, okay? So what will come out will just be simply 2 minus x. So the multiplier for c is c times the quantity 2 minus x. This is just pure algebra. Expand this one, make sure you don't commit mistakes, because if you commit mistakes, there will be a problem in the values of a, b, c, okay? So after the expansion, I will show you the expansion. This is the expansion. And the final expansion will be negative 1 equal to ex squared minus 2ex plus a plus bx squared minus 3bx plus 2b plus 2c minus x. This one is just the expansion of this. So let's proceed with the computation of the value of ABC. Equating coefficient of like terms for x squared, 0 will be equal to a plus b. Okay, x to the first, 0 will be minus 2a minus 3b minus c, equation number 2. X to the 0 power or pure constant, negative 1. Right? Pure constant is all the terms without an x, so it will be 2c. 2c, we got lots. This should be a plus 2b plus 2c. Okay? Negative 1 will be a plus 2b plus 2c. I will venture to the solution of this one. We are just given 3 linear equations in which we have 3 unknowns. So you can solve this by elimination by substitution or other things by using determinants. But I won't venture to that. Okay? After solving for equations 1, 2, and 3, the value of a will be negative 1, the value of b will be 1, and the value of c will be negative 1. Okay? That's just algebra. Okay, very elementary. Therefore, the integral of negative dx over 1 minus x quantity squared times the quantity 2 minus x equal to the integral. We are just following this. We substitute the computed values of a, b, and c back here, and what will come out is this. The integral open bracket, a is actually negative 1 over 2 minus x, plus b, which is 1 over 1 minus x, plus the value of c, which is plus open quantity negative 1. I put a quantity here because this is plus and this minus. Okay? All over 1 minus x quantity square, close bracket dx. Then try to expand, but try to observe first. This is under natural logarithm, this is under natural logarithm, and this is under power formula. But we must have to verify the value of du, the one on the numerator. For the first one, the value of u is 2 minus x, du is minus dx, it is exact. Because minus 1 times dx is negative dx. It is exact. Right? Second one. It's another value of u. Second u is 1 minus x. du will be negative dx. 1 times dx is positive dx, right? But after the verification, du should be negative dx. So I put it here, not exact. So later on, we place a negative sign outside. For the third one, u will be 1 minus x. This is under the power formula. We are just verifying the value of u, or du rather. du will be 1 minus dx, or du is minus dx. Is it exact? It is exact. Because minus 1 times dx is minus dx. It is exact. Okay? So for number 1, this is exact. We don't have to do anything. This is exact. We don't have to do anything. For the second one, we must have to insert the negative sign because upon verification, the value of du should be minus dx. Okay? So rewriting this one after expanding, this should be equal to the integral. Minus 1 times dx is negative dx over 2 minus x. Okay? The second one, 1 times dx is actually plus dx. But supposed to be the du will be negative dx. So I place negative dx here and I place negative 1 outside. Okay? The last part, minus 1 times dx is minus dx. If we try to take the integral of that, this should fall under the power formula. Because this can be written as the integral of 1 minus x to the minus 2 times minus dx. This now falls under the power formula. So the first one, this is the exact value of du and this is u. The answer will be natural logarithm of 2 minus x. Okay, plus and minus will be minus natural logarithm of 1 minus x. Third one, it falls under the power formula. It would be 1 minus x raised to minus 1 over minus 1 plus c. We don't have to do anything because it was exact already. The value of du is exact. Okay, then combining this one. This is plus, this minus, under 1 natural logarithm sign. So this should go under the denominator. This should be natural logarithm of 2 minus x over 1 minus x. Okay, minus, plus and minus will be minus. Okay, we eliminate the negative exponent, we bring it down. So this is minus 1 over 1 minus x plus c. But what is x? Okay, the value of x is actually cosine of theta. So the final answer will be natural logarithm of the quantity 2 minus cosine of theta all over 1 minus sine of theta minus open quantity 1 over 1 minus cosine of theta plus c. Meaning, the integral of sine of theta differential theta over the quantity 1 minus cosine of theta square times the quantity 2 minus cosine of theta equal to, final answer, natural logarithm of the quantity 2 minus cosine theta, 1 minus sine theta, close quantity, minus open quantity 1 over 1 minus cosine of theta, close quantity, plus c. That's it, guys. I make the solution brief and concise so it will not be boring. That's it. Good afternoon, Los Angeles.